Hello guys, it's your boy Mr. TSEBE, and today we will be doing eigenvalues and eigenvectors part 2. So suppose that we are given a matrix like this: 2 1 0 0 1 minus 1 0 2 and 4, and then they are asking us to find eigenvalues and then eigenvectors. But we know that for eigenvalues we are going to say the determinant of A, because of this matrix is matrix A. So we are going to say that the determinant of A minus lambda multiplied by I equals to 0. So but our determinant here of A minus lambda multiplied by I equals to this matrix, which is 2 1 0 0 1 minus 1 0 2 and 4. So this is what we are having, but according to our equation it says we must subtract lambda. So we are going to subtract lambda here, and then we are going to subtract lambda even here, and then we are going to subtract lambda even here. We are subtracting lambda diagonally, and then this we can say equals to 0 0 0, or you can just say equals to 0. So right now we are going to try to find the determinant. So, but we know that the determinant, we are going to focus on this one. So when we focus on this, let me use two things. So when we focus on these two, then this line and this line are no longer there. So the matrix that we are going to be having is this part multiplied by these things, which is 2 minus lambda, 1 minus lambda, minus 1, 2, 4 minus lambda. This is what we are going to be having. So when we focus on this one, we are going to take this root, this part, and then we are going to put this one even here. So the matrix that we are seeing is this part and this one and this one and this one multiplied by 1. So we are going to subtract 1 multiplied by 0 0 minus 1 4 minus lambda. But this is 0, so no need to do anything because of it will just give us 0. So but we know how to find the matrix of 2 by 2 matrix. So it's going to be this part multiplied by this one, subtract this part multiplied by this one. So even here it will just be the same thing. So this will be 2 minus lambda, this part lambda times this one, it's 1 minus lambda multiplied by 4 minus lambda minus 1 multiplied by 2 minus 1. So this one multiplied by this is 0, minus this one multiplied by this is just 0. So this part will just give us 0. So we are going to say 2 minus lambda, 1 minus lambda, 4 minus lambda, and then this will give us positive 2, and then this part will just go to 0. So we can divide by 2 minus lambda, and then even this side by 2 minus lambda. So this one will cancel out this one. So we are going to be having 1 minus lambda, 4 minus lambda plus 2 equals to 0. So those are the values that we will be having, the things that we will be having. So if I multiply by 1 here, 1 multiplied by 4, it will just be 4. 1 multiplied by lambda, it will just be lambda. Lambda multiplied by 4, it will be minus 4 lambda. And lambda multiplied by lambda, it will be lambda squared plus 2 equals to 0. So putting this in a standard form is a lambda squared minus 5 lambda. So 4 plus 2, it will just be 6, which is 0, which equals to 0, all of it. So factorizing this is the thing I'm going to be having. This will be lambda, this will be lambda, this will be 3, this will be 2 minus minus. So my lambda will be equals to 2, or my lambda will be equals to 3. So my eigenvalues were 1 equals to lambda equals to 2, and then another one equals to 3. So let me just record them here. Eigenvalue number 1 is equals to 2, or eigenvalue number 2 equals to 3. So since we're having eigenvalues, we can go and try to check for eigenvectors. So for eigenvectors, this is what we know. So we are going to say that A minus lambda multiplied by identity matrix multiplied by x all equals to 0. This is what we know. But when lambda equals to 2, we can substitute here. It will be A minus 2 multiplied by identity matrix, which multiplied by x, not forgetting it, which is equals to 2, 1, 0, 1 minus 1, 4, 2, and 0 and 0 here. So, but here is minus 2, so we have to subtract even here. But we are subtracting diagonally. And then here it's x, y, and z, which is the same as 0, 0, 0. This is what we are having there. So that is what we are having. So simplifying this will give us 0, 1, 0, 0, minus 1, minus 1, 0, 2. 4 minus 2 is just 2. So this will just give us y, x, y, z, which is the same as 0, 0, 0. So that is what we will be having. So we can just select x to be equals to 1. So we know that when x equals to 1, but here we're having y which is equals to 0. Because if we want to find the relationship between x, y, and z, so we have to let x equals to 1. But from this, our y equals to 0. So we can check this one. It will be minus 2y minus z, which is equals to 0. So my y is 0 minus z, which is equals to 0. So I can see that my z is also 0. So my z equals to 1. So my x, y, and z equals to 1, 0, 0. So when eigenvalue equals to 2, these are the eigenvectors that we'll be having, 1, 0, 0. So let's try for when lambda equals to 3. So when lambda equals to 3, we're just going to substitute here minus 3. Sorry, this will be minus 3 multiplied by identity matrix, and this will be x, and then this one will be 2 minus 3, 1, 0, 1 minus 3, and here is 0 minus 1, then here is 0, and here is 2. This one is 4 minus 3. This is x, y, z, which is the same as 0, 0, 0, and like that, which is 0, 0. So simplifying this is the same as minus 1, 0, 0, 1 minus 2, 2, 0, minus 1, and 1, which is x, y, z, which is 0, 0, 0. So the same way we did it, we have to let x equals to 1. So when x equals to 1, but we have in this equation, two equations here. So we are going to be having minus x plus y equals to 0 from the first. So but my x is 1 plus y equals to 0. So my y basically is equals to 1. So in order for me to find my z, I can use one of the two equations. So I can say 2y plus z equals to 0. I'm using the last equation here. So substituting 1 plus z, then my z will be minus 2. You can even use this equation, you are still going to get minus 2. So our x, y, and z equals to 1, 1 minus 2 when our eigenvalue is equals to 3. We can simplify this further. If we multiply 1 by 1 over 2, this will be 1 over 2. And if we multiply this 1 by 1 over 2, it will be 1 over 2. And then if we multiply 1 over 2 by 1 over 2, it will be minus 1. So if a person writes it this way or this way, they are all correct. So if you enjoyed this video, please subscribe to my channel and then also send it to your mates. And then stay tuned for part 3.